Okay, good afternoon, everybody. Today is 27th of October 2020, and we have about 1 hour for today's session. And I have given you three files, right?
Yes, sir.
And actually, no, three files. So basically, that one file is actually one page of uh, 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 I think on the Ohm's law, I think actually the one file is consists of both pages, page one and page two. But the other file actually is a duplicate of the second page. And I think because of the scan was not that clear, so that's why I resent that particular page. So those are the what I call it the questions that you can do uh, uh, in order for you to have a proper a better understanding on what we have covered in on the topic of units and definitions, and also about the KVL, KCL, Ohm's law, and some of them actually on what do you call it, this parallel and series resistance. Okay, so anybody has started looking at it or not yet?
I have looked, sir, but not do it yet.
Yes, sir.
Not
Yeah, we
yet.
have looked but did not do it.
Okay, so from your first impression, is it difficult or easy? When you look at it, do you have the feeling that okay, this question I can answer, this question I know how to do it, and this question I don't think that I can do it?
Average,
So what's your feel?
average, the
Average,
middle.
in the middle. So basically that you think that you can do it.
Below average, not all. Mostly cannot do it.
Mostly cannot do it.
50-50.
Yeah.
50-50. Okay.
We'll
Let's
try.
go on the first on the first part. Let me put up the question. Let me get this one is on units definition, the assignment one. The title is assignment one. So let me put up the document that so that you can see. Okay. So this one. Okay. The first one. Do you think you can do it? You are given a circuit of with what do you call it, voltage source of 30 volts and connect to a resistor of 5 kilo ohms. And the question is basically that asks you to find the current I, which is the current flowing through the resistors, and also the power absorbed by the resistor. So in this case, the power absorbed and the power generated by the resistor is actually the same as the power generated by the
What's that?
Huh?
Apa di tangan sini? Apa yang datang tu?
Tak tahu ngatang ni apa.
By the power source.
That is actually a voltage source.
The
Voltage
source.
source.
Ya Allah, lupa.
Voltage source is basically that you have the symbol is that plus minus. And number two is actually a current source when you have an arrow. Okay. So it says that calculate the current I and the power P. So how do you find the I?
Ohm's law, sir.
Ohm's law. What is the Ohm's law says?
V equal to IR.
V equal to IR. So therefore I is equal to
over R.
I
V over R.
V over R. So what is the voltage across the resistor?
30 volts, sir.
What is the voltage across this resistor? The V.
6 volt.
Huh?
This resistor.
What is the voltage across this resistor? V. What is the value of
30,
V?
30 volts.
30. 30 volt.
Huh?
30 volt.
30 volt. So voltage is 30 volt. What is the resistor? It's 5 kilo ohm. Therefore, I is equal to V over R. So 30 volt over 5 kilo ohm. What's the value? 6 milliamps.
Yes, sir.
Okay, so because it's actually 30 divided by 5,000. 5 kilo ohm is basically 5,000 ohms. So it's 6 milliamps.
Milliamp.
So how do you calculate the power?
P equal to IV, sir.
P equal to IV.
P equal to IV.
IV.
So I is 6 milliamps times
T 30 volt.
Volt.
so equal to 180 milliwatts.
Kilowatt.
Easy, right?
Yes.
Number 2. You are given similar circuit, but now you have a current source instead of the voltage source, and you have a resistor connected to it. So the current source is 2 milliamps connected to the resistor of 10 kilo ohms. So you need to calculate the voltage
Using
and the
Ohm's law, sir.
conductance G and the power P. So what is the voltage across the resistor? V equal to
IR.
IR. So what is I in this
I
case?
is 2 milliamps.
Milliampere.
2 milliamps times R of 10K. So what? 20
24.
ohms. What is G? Conductance. What is conductance? The one that you use the unit limit. Conductance is the reciprocal of resistance. So 1 over R.
1 over 10.
1 over R. Resistance.
Or 1 over R.
Conductance. Conductance is the reciprocal of resistance. So 1 over R. G is equal to 1 over R. So 1 over 10K. So is 100 microsiemens. Okay. What is the power? Power is IV.
IV.
I is 2 milliamps times V 20 volt.
20 volt.
So you get 40 milliwatt.
Watt.
Okay. Simple. Number 3, the one that you need to give the definition. What is a branch? What is a branch? What is a branch?
Branch is any position of a circuit with two terminals connect to it.
Two
Okay.
terminals.
Two terminals connect to one circuit. A circuit with two terminals.
Okay. Or elements. Elements. Okay.
Equal number of elements, sir.
Huh?
Elements.
Okay. What is a node?
The point by connection between two or more branch.
Yes. It's a loop.
Loop is a
Any closed
path
path
through the
pass
circuit.
through the circuit.
No node is encountered
There
more
is
than
no node in encounter more than once.
Yes. Element in series. What's the definition of elements in series? when element is series is when elements connected in such a way that the current flowing from one element to another element, basically that the all currents, 100% of the current flowing from one element to the another. Betul? Check your notes.
Sure,
Okay.
sir.
So number 3. So elements in parallel, basically that when you have the when the terminals of two elements are connected to each other, and basically the current flowing is divided between those two elements. Number 4, determine the number of branches and nodes in the circuit shown. So you have these circuits. So how many branches?
5 branches.
So what are those 5? Can you tell me?
AB is
No, branches. What are the branches?
5.
Yes, you have 5. What are the what are those elements?
the
The 5
resistor,
branches.
Voltage source.
One is voltage source of 10 volts.
5 ohm,
Then
Resistor.
Resistor with 5 ohms.
5 ohm
5
resistor,
ohm, 2 ohm,
2 ohm resistor, 3 ohm
3 ohm.
resistor, and
Current.
2 amp current source.
Current source.
Current source 2 ampere.
Then how many nodes that you have?
2.
3.
3.
A, node B, and node C.
C.
Okay.
sir.
Okay. Number 5. Determine the number of branches and nodes in the circuit shown. Identify which elements are in series and which are in parallel. So,
3 branches.
4 branches.
4 branches.
okay. Basically that when you want to identify the branches, you count how many elements that you have.
Yeah.
So in this case, you have 4 elements.
Element
So therefore, you have 4 branches.
branches.
How many nodes do you have?
3 nodes.
3 nodes. So this is 1 node,
1,
another 2 nodes, is the third node.
3.
Okay. So how does how do these elements are connected? 10
Yeah.
and
Then 5 resistor.
in series, 6 ohm and the current source in parallel. And this actually 6 ohm actually also in parallel with the series of 10 volts and 10 volt source and 5 ohm resistors. So actually this part is actually in parallel with this part. Next. This one that you need to do some calculation on your own. Boleh?
Yes, yes, sir.
Okay. Find the current and voltages in the circuit. Okay. Can you see the my screen? Can, right?
Yes,
Okay. So you have 5 volts voltage source. You have 2 ohms resistor, 8 ohm resistor, 4 ohm resistor, and 3 volt voltage source. So can you find the currents and voltages in the circuit?
Yes.
Right.
For your whole thing out.
Can you do it? I1 is basically that the current through the 2 ohms resistor. I2 is through the 8 ohm resistor. I3 is through the 4 ohms resistor. Susah sikit lah yang ni lah. Need to do some calculation. Siapa dah boleh buat? Siapa nak cuba? You want hints how to do this?
Yes, sir.
Okay. V2, okay. One equation is V2 is equal to 5 volt minus V1. And another equation is that V2 is equal to V3 minus 3 volts. So you try. Boleh? Dapat tak? Okay. Boleh buat. Kalau tak boleh buat, this one you submit as assignment. Okay. Number 7.
Okay, sir.
Number 7. You have 100 ohm connected to 15 volt voltage source, and you have actually a switch. First at the position 1, then you need to find the current I. There is the part A. Part B, you switch the switch from the position 1 to position 2. So basically that voltage source connected to the
Position 2.
150 ohm resistors.
Yes.
So you have to find the I for part A and part B. So what is the part A? What's the current?
0.15 ampere.
15 divided by
15 divided by 100.
100.
100.
so that is the current. For the other one, part B,
15 divided by 150.
150. Okay.
0.1.
2.1 ampere.
Number 8. Find I1, I2, and I3. So this is using the
ACL.
KCL. So you will get the answer 14 amps minus 2 amps and 10 amps.
10 amps.
Right? This one you can do it, right? This one basically that you calculate the node here. You use the node here to find I1. So I1 is going in, and you have the I2 going out, and you have 2 amps going out, and you have 12 amps going out. So therefore, I1 is actually 12 plus 2, 14. So for I2, you calculate at this node here. You have 12 amps is going in, and you have 14 amps going out, and you have I2 is going out. So therefore, I2 is what?
10 ampere.
2, but the arrow is going into the node, because the summation of the current entering the node must be equal to the summation of the current going out from the node. So the one is this current is only 12 amps going in, and coming out is 14 for this one. So therefore, the remaining one has to be coming in also of 2 amps. So that's why the sign is minus 2 amps, because of the direction actually the opposite from the one indicated on the circuit. So I3, so I3 is basically you calculate from this node. So you have I2 actually coming out from this node of 2 amps, and you have another 8 amps is coming out. So therefore I3 is going in is 10 amps. Okay. Number 9. Calculate V1 and V2. So which one is V1? This is V1, this V2. So this one is basically that, you see, this is actually quite similar to this. The only thing that is reverse. Okay. So you have 5 volt here. And this one is 1 volt. This is V1. This 2 volt, that's V2. So the voltage here at this point, at this node, is 5 volt because let's say you put A here. So VA minus 0 is VA. So VA is 5. So 5 volt here. So therefore, 5 volt here is actually is equivalent to this 1 volt plus this volt, this one. But you have to look at the sign. This is plus sign on top. So this is plus sign on top. So basically, 5 volt is actually equal to V1 minus 1 volt. Okay, because of the sign here. Okay. So V1 minus 1 is equal to 5 volt. So therefore, V1 is 6 volt. Here, this is 5 volt here. And you get the sign. Plus on top and plus.
Yeah.
So it's actually V2 plus 2 is equal to 5. So therefore, V2 is 3 volts. So you use similar here, a similar method to solve for this one.
Okay.
Right? Okay. This one, find V1, V2, and V3. So basically, you need to find the voltage across these resistors. So what is V3 voltage?
V3.
What is V3? Voltage for V3.
Yeah.
Remember, the parallel elements, basically the voltage is the same between the two terminals. So, what is the V3?
Volt, sir.
What is the value of V3?
Value
10
10
volt.
volt. So
10
V3
volt.
is 10 volt.
Because it's in parallel with this 10 volts. So V3 is 10 volts. So from here is 10 volts. Right? So V3 is 10 volts. So if this is 10 volts, okay, what is V2?
V2.
10 volt plus 12 volt.
V2
So
is
22 volt.
12 volt plus 10 volt.
10 volt here plus here. So you get this.
So
But the sign
minus because the plus here. Because this one is plus here and plus here, but the sign given in this diagram is the other way around. So therefore, it's minus 22 volt. Okay. So what is V1? If 10 volts here,
Yeah. V2 is 20.
So this one is, remember, is minus 22, right?
Yes.
Why minus 22 plus 24?
Plus 2 volt.
2 volt.
2. Because the total in this loop must be equal to KVL.
Negative 2.
Should be
It's been
0.
negative 2.
The total should be 0 here. So this is minus 22 plus 24
Plus 2.
minus
get
V1.
2, right?
Yes.
So this is basically must be 2 volts. Okay.
Okay, sir.
Number 11. Find I, the power dissipated by the resistor and the power absorbed by each source.
The power.
Okay. So
So
This is given the circuit. So how do you find the I?
I equal to IR. So
I equal to V
V
over R.
R.
What is the voltage, total voltage in that circuit?
26.
20 minus 4 is 16.
16.
16 minus 10?
Oh,
6.
6 volts.
Huh?
6 volt.
16 minus 10 is 6 volt. 6 divided by 3?
By
2 sir.
2 amps. Because this one is, this one and this one, actually, you look at this. The plus sign connected to the minus sign. So you can add these two.
Okay.
And this one is plus sign connected to the plus sign. So this one minus that one.
So,
So then you have a plus sign here, minus sign here, because the current is flowing this way. So it's 2 amps. Power dissipated by the resistor. How do you get power resistor? Dissipated by the resistor. I square R.
yeah, I squared.
I square R.
Yes.
Okay, so I square is R. So I square is 2.
2
Square
square
4. 4 times 3 is 12 watt. And the power absorbed by each resistor, each source. When you say power absorbed, so the sign,
Power is up.
so the sign is negative, right? So basically VI. So this one is 2 multiplied by 10.
20 watt.
2 multiplied by 10 is 20. Okay. 20 multiplied by 2 is 40 because the current is this way.
Negative.
Okay. So and it says that power absorbed is actually power generated by this one. Current flowing out from the positive. So it's power generated is 40 watt. So when it says absorb, so we have put a negative sign. So 40 watt. And this one, current is flowing this way. So it's actually absorbed. So this actually absorb the current. 2 times 10, 20. So the current is going into the positive sign, so it's positive. So actually absorb is 20 watt, positive sign. And this one is current is flowing out from the positive sign, but you see this, the value is minus. So actually, in actual fact, the positive sign is this end. So that's why it's 8, 2 plus 4, 2 times 4 is 8 watt. So this also absorb the current, the power. I mean the power, not the energy. The power. Energy is in joule. Power is in watt. So yeah, this one. You have a current source, and you have these many resistors. You have to find the Vx. Can you solve this one? In order to solve this one, you have to use the
KVR.
Concept of parallel and series resistors. How you want to combine. So where do you start first? Here.
From right to left.
It depends. It depends. So this one you can combine because this one and this one is parallel. 8 parallel to 12. So
4
have to take 1 over 8 plus over 12, take the result. So you get the value here. Then after that, the resultant resistance is really in series is with 1.2. So you add with 1.2. Okay. So now you have this one resistor here. So this one and this one can be combined because it's in parallel. 3 parallel with 6. So 1/3 plus 1/6 and take the reciprocal of the result. So therefore, the resultant resistance is in series with 4. So you add. So now you have this resultant resistance is actually in parallel with the resultant of this resistance. Then you can start doing to find the Vn. Okay, that's how you do it. So you continue from there. So this one, you need to find the I1, I2, I3, I4, I5. So the same thing, you find the I1 first. How to do that? This one you can combine in a parallel formula. Then it's also parallel with this one. So you get one resultant resistor here. So now you can find the I1. And from there, then you can start to break it. You start to use the current divider. So I1 actually a current divider between 4 amps and the 1 amp parallel with 2 amps. From there, then you can find the I2 and I3. And from I3, you can use current divider to divide the current between 1 ohms and 2 ohms. Then you get the solution. Okay? So that's how you solve. Number 14. You have 50 ohms and you need to find you have 50 volts and you have 4 resistors connected in this way, and you have to find V0 and I0. Okay, so you have to try on your own for this one. This one you have to find the value of R. So this one basically that you need to find the what first? Voltage. It is given the voltage. Therefore, you can find this. You can use the KVL with and use with the combination of Ohm's law. Right? You do on your own. Yeah. Number 16. Find the V0. Simple.
Okay.
Use the KVL. Okay. This one, you have to find the equivalent resistance. Use the concept of series and parallel resistance. How to combine. This one is so if you look at from this way, from the left, so you have to start doing from the right. You start to do you have to combine from the right, not from the left. Right?
Right.
Number 18. Find the equivalent resistance seen by the source and the current I. So when you want to find the equivalent resistance seen by the source, what you need to do is that you take out the source. Take out the source, then it becomes an open circuit like this.
Okay.
Basically, this is actually originally the source is here, but you take out. So then R equivalent is from this side. So you start from this side. You start your calculation from this, from the right going to the left. Okay. Then you find the equivalence resistance. Then after that you can find the I. So this one is also find the R equivalent or RAB. So this one you start your calculation from the right. Right? This one, find IO, I0 and V0. Calculate the power dissipated by the 3 ohm resistor. So you have to find I naught, V naught, and power dissipated by this resistor. So this actually you can find using the voltage current divider. How to do that? First, you combine this 6 and 3, 6 ohm resistor and 3 ohm resistor using the parallel formula. Then you can find the I. And when you can find the I through these 4 ohms, then you use a current divider to find the I naught. Okay. When you find the I naught, therefore you can find the V naught. And from there, you can calculate the power dissipated at these 3 ohms, which is I naught times V naught, IV. This one. So R equivalent. So you start calculation from the right. This one. Redraw. You redraw this, then you can see the circuits. So you need to find the R equivalent between A and B. So we can try to find A and B. So therefore, we start from this bottom here.
Okay.
This is the same thing. R equivalent from AB. So from here, you can see you can use the formula for R for series and parallel. So this one,
V1, V2.
find V1 and V2. So V1,
V2.
V1 and V2, okay, and I1 and I2, and the power dissipate in the 40 ohms resistor. So the same thing, you can use the KCL, KVL, and Ohm's law, right?
Okay.
So this is the one exercise. This is actually assignment 1. Another one is, wait, let me open the other one. Okay, this one. You see the slides now?
Yes, sir.
Which one you see? Ohm's law.
Ohm's law, Kirchhoff law, current and voltage division.
So this one. So the first one actually is the same, right? The what I call it as before.
Yeah.
Number 2 also is the same, right? This one also the same.
Yes.
The only thing is that maybe the value, the value also the same. This was the same. This also the same. This one same, right?
Same.
So this is also the same, right? So we have covered all actually just now, right?
All right.
So, but you just go through this one just in case that there is some call it difference, but I think it's the same question actually. For the 10 question initially is actually from the first set, right? So you do that, and you can submit to me. This actually consider as your first assignment, okay?
Okay.
Okay, sir.
And hopefully that you can do, because I have shown you, at least give you hints how to do it.
All right.
Okay, sir.
Any questions?
No questions, sir.
No question. If no question, then basically I can stop sharing.
Sir,
No, sir. I forgot to ask.
So okay. So
When to submit,
I
sir?
stop sharing the file. By the way, the attendance. From the last 3 lectures, Akila, he has dropped this course, I think, because her name is not in the list anymore. One is Hasik. Attend the last 3 lectures, and I don't think all of you can contact him or not.
No, sir.
No.
No, sir.
So I actually have contacted the Ketua Jabatan, and it seems that maybe he's planning to drop out from the program. So we have actually now 26 minus 2, so it will be 24 students. And today I think about 2 students is not online. So do you have any question on what we have gone through today?
Entah bila esok.
Hantar bila? I give you 1 week lah.
All right, sir.
Yes, sir.
So I give
Thank
you 1
you,
week.
sir.
Yes?
Nothing, sir. Nothing.
Nothing. Okay. So anything, just message me on WhatsApp. You can ask on WhatsApp. So
Alright,
I
sir.
give you 1 week to do. And if you don't have any question, so therefore I will end this lecture and see you next week. Next week we'll continue with the mesh analysis, and also we'll do the tutorial on nodal and mesh together.
Yes, sir.
So I stop the recording now. See you next week. Thank you.